Good morning, everyone, and welcome to this week's webinar. This week, our fearless leader, Jeremiah, is actually away and hopefully enjoying some rest and relaxation. So myself, Damien, is here to facilitate this week's webinar. I've also got Jake kind of answering some questions on the back end for you guys. But today we have a pretty progressive and some might actually say a contentious topic in the realm of irrigation design, traditional irrigation design. However, it's a really interesting one because it addresses a problem and provides a really viable solution in an already broad and diverse market. So today, presenting this topic, we have Irrigreen's CEO, Shane Dyer, who's going to be the majority speaker, and Ray Lamavec, who is going to be supporting Shane in answering any live and technical questions. But before we get started, I will address our usual housekeeping items. If you have any questions throughout the webinar, please type them into the Q&A box. Jake and myself will be managing those. Some questions will be answered directly. Otherwise, we'll have a moment possibly throughout the slideshow where we can interject and ask those relevant questions. Otherwise, we'll wait until the very end and have some question time. For now, I'm actually going to hand it over to Shane so we can get this presentation underway. Take it away, Shane.
Damien, thank you so much. Can you hear me okay?
Yeah, it's
Wonderful.
great. Thank you.
Wonderful. Well, thank you so much for having me on. I'm Shane Dyer. I'm the CEO of Irrigreen. And we're really excited to talk to you about something that's pretty new, although it's been around for about 3 to 4 years now in testing, but really changes the face of irrigation. And like anything else, as we get into it here, we'll talk about the ways that it's similar, but also the ways in that it's a very, very different paradigm for thinking about irrigation, but unlocks some really incredible water savings and other benefits that actually make it much easier to design beautiful landscapes. So we'll kind of start out and go through, why, what the need was to create digital sprinklers, what need they fill. We'll talk a little bit about the design rules and how you design with this brand new sort of paradigm in irrigation. And then at the very end, I'll go into and we'll do a video on a case study at the Oklahoma State Botanical Gardens using digital sprinklers. So starting off from this, the first one is that, one of the key benefits of digital sprinklers is they save a lot of water. In most cases, off a very efficient system, about 40% of the water. And if we look at how water is used, and we're not going to use a commercial example here, we'll use a residential example, but most of our drinking water is going actually out into our yard. We're putting it on our plants to have the beautiful landscapes around us. So the low flow toilets, the restricted shower heads aren't really going to help change this problem. It's really up to us in this industry to figure out how we can save water and still have beautiful green landscapes. So about 4 to 5 billion gallons are wasted daily in inefficient irrigation. And as you look at this, we're all used to seeing overspray and other pieces like this. We talk about about somewhere around 50% of the water, in many cases much higher than that, is not helping the plants grow, is actually going to the wrong area or oversprayed or anything else like that. And that's according to the EPA. Mechanical sprinklers are something that we're all very used to, but this is a technology that's been around for a very long time. There's been some innovation, like we talk about MP rotators and things like that as well. But really, they can only do so much, sort of crude mechanical patterns and arcs, things like this as well. And also the fact that we design them to be overlapping, by definition, causes kind of wet and dry spots. So I think there's a lot of, there's a lot of emphasis in the industry of, sprinkler systems that are there wasting water because they're poorly designed or they're poorly installed. But it turns out even if you design them well and you install them well, there's still some significant drawbacks to the ways that we currently do irrigation. So as an example here, the diagram you see, each of those blue circles there is a sprinkler head. And this is a pretty efficient system. This is like a 0.65 DU system, distribution uniformity system. But you can see in order to get what they call the lower quartile, each of those sections there that says 100%, and we'll use a turf example here. from turning brown in the summer, we're actually overwatering most of the rest of the landscaping. So for instance, those big areas in there where it says 195%, those are getting almost twice as much water what they need. So this isn't even necessarily helpful for the plants to receive that much water. And so you can see why even in a well-designed system, there's a lot of waste and overlap. And that's not even counting the overlap that we see in overspray, the fact that we can't get these things, the precision, especially a system that has been operating for a few years is below ideal. So that's really where digital irrigation came in. The idea of putting water exactly where we need it. And the paradigm shift we'll talk about here is going from a system where we're mechanically spraying water to a system where we're actually doing something that's much more close to printing water. We're using a lot of the same techniques that are used in inkjet printing. In fact, the inventor of this system, the first digital printing system, the digital irrigation systems, Gary Kleinfelter, came from the printing industry. So if you think about when you print a picture, you actually have to take liquids and put them in very precise places and then make sure you don't put them where you don't want them in order to have a picture. A very similar system is being used where software is actually involved in placing water exactly where it's needed and not placing water where it's not. So, they say a picture's worth 1,000 words and a video's worth more than that. So I want to show you right now the system in action, and then we'll kind of break down the parts. So here's an example of a digital sprinkler head that's actually computer controlled popping up. And it has over 14 ports where it's actually sending that water off and providing a completely even distribution of that water to go through. And we'll talk about how we program this. We actually end up using an app on our phone where the installer of the system, once the head is there, will use the app to basically draw the shape. But the point is that as it goes around, it's changing the time, the speed at which it moves, and taking those 14 streams and putting them at different distances to provide that completely even distribution of water across any arbitrary shape. So the components of this system are first a controller, which is very similar to any controller that you'd have in a system, except it's designed to support digital heads. The sprinkler head itself, which is like a valve in head design, so very much like a golf sprinkler. It has the valve there as well. So there's low voltage wire that runs between the controller and the sprinkler head. Runs in the same. It's waterproof. It's plug and play. It runs in the same trench as the main line that you use to connect to the sprinkler. And then for programming, you use the app basically to draw the shape of the area you want to irrigate on this part to go through. So once you have that, you basically go through and those are the three main components for the system. And because the controller has Wi-Fi, there's one coming out this year that also has cellular for more commercial sites. But this allows you to do things like bring ET weather data down. And also because each of the sprinklers are instrumented and there's a flow meter in the system, it's possible also to understand if you have leaks, if there's a problem with the system as well. So you get kind of a smart service part to it as well. Okay. So let's talk about software controlled shapes, because this is going to be very, very different from the way that irrigation is designed now. So in a traditional irrigation system, to irrigate an area like this, you might have your heads placed, a main line down the center and then laterals, controlling this particular zone. And those laterals would connect to heads that were placed around the middle. And if it's a larger area, you might have heads in the center as well. Well, and each of those particular heads would basically come off in an arc to go through and help cover the area. And you do the standard head-to-head design where you basically have one head spraying to the other head. Well, with an Irrigreen system, it's a little bit different than that. You're going to have one head that's placed in the center. And then when we program it, we're actually going to put the points using the phone, use the system in the field afterwards, like a squirt gun. So we'll design it so it doesn't have to throw any further than the maximum distance it can throw, which is generally about 30 feet. And then we'll actually program it to follow whatever arbitrary shape of landscaping we've got, we're deciding to irrigate. So one head per zone, you can do any shape. And then the software is also going to control the precipitation rate. So a lot of the calculations that we're used to doing for irrigation, so for instance, understanding working pressure, understanding the flow rate for the various heads, and then doing all the math in an ideal solution to put that together to have an idea of what the inches, number of inches put down over a particular time will be. Well, all that's calculated for you, and we'll talk about that as we go through as well. So what you need to know for design is that the head can throw, the smallest distance it can throw is about 5 feet. If it's less than 5 feet, that doesn't keep the head popped up on that. So so you need to have at least 5 feet of throw. And the maximum throw is about 35 feet. So design-wise, we say throw about 30 feet or so. And we'll talk about how that varies with the amount of pressure you have available at a job site. The head waters evenly from 0 inches, varies all the way up to 5 to 35. And this is a little bit different than traditional irrigation. And I mentioned this before, but you're going to hook up 1 inch direct main line to each of these heads. So instead of coming off a lateral or a valve, the valve is actually in the head. And you have the ability to put like a master shutoff valve or something else like that, or if you want to do for that main line. But that basically takes a lot of the complexity off the piping that needs to be put in there. And as we mentioned before, it's a valve and head design. Also, most of the systems that digital irrigation is designed in are hybrid, which means they might have some drip or some spray in them as well. So for instance, if you're doing shrubbery or things the pop-up right now is about a 5-inch pop-up. So if there's taller plants or things like that you need to get with traditional drip or spray, the system supports those, and those are just controlled like a normal controller would control them. Okay, in terms of requirements, the water pressures usually needs to be between 40 and 80 psi. Any constant pressure between there works fine, and somewhere between 8 to 10 gallons per minute flow. If you're in an area like a non-municipal water source that has particulates in it, in many cases like pump systems are similar, if you've got grit in there, then it's just like a drip system. You need to have a filter in there. Also, if you have a well system, it's important that there's like a constant pressure pump or a regulated constant pressure supply, such as a pressure regulator in the system as well, to keep that constant. Okay, so when we talked about any shape that you can think of to design, this actually gives you as a designer much more flexibility in the kinds of shapes you can put in, especially for areas like turf. And I know in California, as turf sizes start to decrease, as people want grass in there, it's really interesting to be able to do, strange shapes, kidney beans and things like this, things that were very difficult to irrigate efficiently before. In these cases, you're just putting one head in the center and then being able to do and being able to put them in there. The system has the ability to map like 437 points. So you can draw basically any arbitrary shape. And the increments that basically move by about 6 inches or so, in terms of granularity and where you want to put the stream. The other piece you can do is you can always put the heads on the side. So if you're doing if you're doing a simple system that may have lower throw and you need that 5 feet, like for instance, let's say we're doing a 10-foot by 5-foot strip of grass, the head can be placed on the side and spray out to those various areas. And the software basically connects the dots. So if you, for the instance, let's say, look at the pentagon on that side, you really only have to describe 4 points in that particular area. And remember that this is being done at installation time. So at the time it's being installed, we'll talk about how the software works, but you're basically just spraying it out and going through that. So it's a really amazing system in that you can, essentially put one head in the center of a zone and then draw whatever arbitrary pattern you want it to water. And then after you set up a schedule, that sprinkler head will continue for 10, 15 years to describe that same pattern and put water down completely evenly across that zone. So if we take a conventional system here, and this is an example, we'll use a residential example for this right now. You can see basically you can see the overlapping arcs that we put through here as well. You can imagine the main line going through and then also the laterals out to the various zones to support this. So this is a system that has about 40 heads in it, which is pretty typical for a medium to larger size residential system, and about 1,500 feet of pipe. So if we were to look at the same project and doing it with a digital sprinkler system, you're basically replacing those 40 heads with 5 heads. You're putting those 5 heads in the center of each zone, and each of those individual sprinkler heads is doing just one of those zones from there. So one of the things you notice is, the number of heads reduced, but the other thing is the amount is significantly too. So we've gone from 1,500 feet of pipe down to about 200 feet of pipe, and also down to about 5 heads. So I think this is a good part. Damien, do you have any questions that came in? It'd be good to answer now.
Yeah, we do have a few questions. The first we'll try and get answered, I suppose, because I know that this one doesn't come up through the rest of the presentation, is the actual cost of the single head. Sean was asking that.
Yeah, so digital heads, they're more expensive. They cost about $200 for each head.
Okay, and you certainly cover some cost, I guess, analysis or comparisons between, or I guess the overall differences between equipment per system, but
Yeah.
Leland was kind of asking, covering the cost of the traditional versus digital system overall. So I think that one's a little tough to answer, but yeah, if you've got any insight on that.
Sure, we'll get to a slide on this later, but one of the big differences is that the materials, like the digital sprinkler heads, are more expensive than standard sprinkler heads. However, the labor to put them in is about a third. So as an example, for like a residential example, 2 guys in a truck on a crew will put in an Irrigation system in 1 day, whereas a typical conventional system, that'll be like a 2 to 3 day job. So if you look at about a third the labor, what happens is, for a typical system, the equipment is more expensive. They're somewhere around, in some cases around $2,000 between the controller and the other equipment that needs to go into an installation, which is more than you would pay for traditional sprinkler heads. But then the labor going down by 2/3 helps make up for that. In residences, it tends to be about $1,000 more expensive for a job. So in general, somewhere on the order of a $4,000 or $5,000 for digital sprinklers versus, $3,000 or $2,000 for, this is sort of for low-end residential. Now, as you start to get more heads and get into commercial, it starts to even out and be almost cost equivalent as you add to, get to sort of 5, 6, 7 zones.
Okay, great. And one last question I think we'll do for this like intermittent portion was the actual dimensions of the body of the sprinkler.
Ooh, that's a good question. Can you give me, Ray, do you want to jump in on that one?
Yes, the head is about 11 inches tall, and that bottom diameter is about 5 inches in diameter. Now, the pop-up then is another 5 inches. So when the head is fully extended, it's 16 inches tall. So it does go a little deeper than standard heads.
One other part too is we've actually seen these things used in areas where water accuracy is extremely important, which is rooftop deployments. So that's been a really interesting market for using digital irrigation, because making sure that you're very accurate around what you're watering is important. One of the other key benefits was, if you actually looked at that video with the streams, you saw the streams were semi-coherent coming out in fairly large droplets. So the Irrigation system tends to be less affected by wind. It's still somewhat affected, but less affected by wind by most sprays or even rotors, because we're streaming that water versus spraying it. One of the other key benefits is also droplet size. As you saw in the video, and you'll see in the case study video at the very end, the droplets are actually quite large, which means that they have the ability to basically penetrate underneath, bushes or turf and get down into the root system, versus being small drops on the blades of the grass that evaporate quickly. So there's a couple benefits there, and we'll talk about a few others as we go through.
Yeah. Okay. Well, I think that's all the questions we'll keep in for now, and we'll keep on going the presentation.
Perfect. I'll keep going here, and please keep them coming in. We love the questions. That makes this more fun.
Perfect. Okay.
So digital irrigation is really this kind of paradigm shift. One of the things that we notice is it really simplifies the design of the system as well. When you're designing these systems, essentially what you're looking at is you're looking at your ring, which is your maximum throw distance, and we'll talk about how that's dependent on pressure. that sits in the center. And generally, we're designing most our designers are designing for about 30 feet. It can throw a little further than that, but that's kind of a nice design size. And then making sure that you are within, you know, that particular sprinkler has line of sight to everywhere it needs to water. So for instance, if you had a big, you know, a big box or something else like that to go through, you'd have to figure out how to arrange the heads so that at least one head had line of sight to the things that needed to be irrigated. It simplifies, so that's the design side. And in terms of the water flow rate and everything else like that, once the system goes in, you basically know for a given shape and a given size, you can figure out how many gallons per minute that particular head will throw, and also what the run time will be to put those number of inches down. It also simplifies installation. You know, just tons less digging and installing. And also, you can be a little less accurate in where you put the head. You know, if the head moves by a foot or two or anything else like that, because it's digitally programmed after installation, you have the ability basically to make any, you know, overcome any of those difficulties on that. And you know, the other part is there's a big standardization piece here. One of the things you'll notice is that every one of these digital heads that we're putting in right now is the same SKU. So versus standard irrigation, where I might choose from 1,500 different possible SKUs that I could put in and select exactly the right one to try to build those complex shapes. In this case, those complex shapes that I need to water are built in software. So I'm just using one standard digital sprinkler head, and then all the variation in irrigation occurs in how that sprinkler head is programmed. And just one note on this, you know, there's a lot of, you know, smart controllers. Obviously, Irrigreen has a smart controller too, to bring things in like ET data and so forth. But that's not the same thing as digital irrigation. We really consider digital irrigation being actually having smarts at the place where the water's delivered. So a smart controller driving a dumb mechanical system is not a smart system yet. A smart controller with a digital head really becomes a smart system, and that's where that, you know, that 40% watering savings comes in. So we saw the first diagram, we'll talk about it in a minute, but when we pop up here, you saw those individual streams dropping water. And if you looked at the distances they were dropping the water in, you'll find that they're all within about 6 inches, which happens to be, you know, for worst case, you know, soil like a clayey soil, the maximum amount that we can trust the soil to basically move that water. So if you had a system like a Netafim system or something else like that, generally they're on 18-inch centers, but imagine one of those on 12-inch centers. You're using the same soil transport capability to be able to move that water, but probably can't move it more than about 6 inches or so. So at the end of the day, if you take this into account, the ability for the soil to move that water, you get almost completely uniform water distribution. And because of the digital, you have the accuracy, so you don't have any overspray or waste in that particular area. So you're basically going, you know, from this, where we're putting down that completely green section, you know, away from what we're doing with traditional irrigation systems where we have that overlap. And that's where the majority of the savings in the system comes from. So in 2016, we actually took the system to Center for Irrigation Technology. This is at Fresno State. They do a lot of the, you know, arbitration on irrigation efficiency. And they did a test where they basically took two or three plots of turf in this case, and they put in, a very efficient mechanical system. I think they used MP rotators on that part to do with about a 0.7 distribution uniformity. So really well-designed mechanical system. And then they took tons of soil moisture sensors all the way across that system. And what they found was that the Irrigreen system used 40% less water to get the same soil moisture, uniformity across that particular plot. So over the very best mechanical systems, you're saving about 40% of your water. And this is one of the key drivers, especially in areas where water starts to become expensive, or for customers where water is a priority for them. The other thing they noticed is that they only needed one digital head in each of those areas, and it reduced the number of mechanical heads that they had about 6 to 9. So they went from 6 to 9 heads down to one digital head in order to be able to do this. So on the software side, you know, essentially what we're doing here is removing a lot of the complexity from irrigation. So instead of thousands of SKUs, you're basically, you know, putting in, you know, one particular sprinkler head per zone, as long as, you know, each of those zones doesn't have to throw more than, you know, more than 30 feet. And then putting the sprinkler head actually in the center or on the side of those zones. So in a case of this particular, there's a drawing of a particular property here where, you know, these digital zones, these 5 digital zones replaced about 38 rotors. And then at that point, once you've placed that and you've verified that, you know, you don't violate the minimum and the maximum throw distances, you're done. At that point, all the programming will actually take place at the site in order to be able to draw those irrigation shapes on that side to go through. And what's great about that is there's always a mismatch between theoretically what you're calculating in terms of irrigation and then the facts on the ground at the site when it's actually installed. So the actual pressure, the system has a flow meter in and will calibrate itself when it's in the field so that the actual pressure and working pressure at each head is taken into account when that programming takes place to make that perfect, to draw those perfect shapes and to maintain those perfect shapes for the irrigation patterns. So here's a case study we wanted to use. This was one in Twin Falls, Idaho. And we'll kind of go through the history of this particular piece, but they had a pretty high efficiency mechanical system. They were using 38 MP rotators, a ratio controller, and they had about a 0.7 DU or 70% uniformity system. So it was a well-defined mechanical system. And then across this, they took that system out, including the ratio controller, and replaced it with Irrigreen in 2017. And across that, you can actually look at the water consumption from 2017 to 2016 here. And in this particular case there, but they saved about 70,000 gallons, and this was a residence at the residence in Twin Falls at the time. The other key piece here is they were in the 5 digital sprinklers they were able to do with only about 200 feet of pipe. So we'll go through those results in more detail. This is a pretty interesting test bed because it had been used as a test bed for looking at water savings technology for a while, all the way back to like 2009 to 2014 when they were using a Rainbird SMT smart controller. They also did soil moisture sensors, and you can see the year-over-year savings. So this has been a constantly optimized system, about 20% with the soil moisture sensor. They used ET weather data through like a ratio system and got an additional 10% savings. But then I think what's most astounding to me is that very efficient system where they had a ratio system, you know, using the MP rotator sprayers, you know, which is a pretty efficient sprayer rotor system. When they put in the digital system, they saved 40% over ratio in that current system there. So, you know, at the bottom there, they talk about what was in before to go to digital irrigation. So there, you know, the water savings is one of the key features that's really driving adoption of digital sprinklers over mechanical sprinklers. And then here's his 2017 results, and this is just a picture of the water bill after that. And this, to give you a piece, is about a 5,500 square foot lawn. So you can see the, you know, the blue, which was the 2016 piece as well. And then if you look at 2018, you see it in the orange there, and significant savings over the previous system. So, you know, with any new technology, usually they end up being much more complicated. However, certain sort of breakthroughs end up simplifying a particular industry. You know, if you think about an example like Uber, for instance, you know, that's just a much simpler way to do a taxi cab company, right? You know, everyone has smartphones, then you don't need radio towers and radio dispatch and 800 numbers and dedicated cars and all these other features, you know, billing systems that taxi cabs used to have. In the same way here, you know, if you look at traditional irrigation on the left-hand side here, you know, one of the biggest parts is, you know, the expertise needed to design and also the expertise needed to install, you know, a current irrigation. You know, essentially we're kind of building these mechanical computers who use, instead of electricity, use water, and then gizmos, basically mechanical controllers to try to spread that water out as evenly as we can. So that expertise there, especially in terms of, making sure, our installers know how to get it right, for the landscapes that we design. Right now, we're just asking for a regular worker. The only thing they need to do, because what that expert did before is now completely in software, they just need to have a tape measure to make sure that they, we're not asking to throw more than 30 feet. The other part is that, we talked about this before, but, those 40 mechanical heads that were chosen from a, universe of, 2,000, 1,500 possible parts we could have used to make whatever shape, shape patterns or, that we need to do in order to be able to irrigate, now get replaced with 5 identical digital heads. So this is kind of like, Henry Ford showing up to this industry. The fact that the SKU counts, go down significantly means that, the ability to have spare parts and things like that becomes much simpler to manage. And in terms of also the complexity, I think a lot of times the customers, have to spend a lot of time, repairing and taking care of all of these heads. Come springtime, how often do we hear complaints from our customers about, they had to go through and have someone come out and replace 4 or 5 heads, or they have 1 or 2 heads that are always behaving badly. So kind of managing that herd of heads, there's a lot of pain in that right now. And when we reduce that number to a very small number and we make sure those heads are monitored, so if there's anything wrong with them, they actually let us know what's wrong with them, low flow or high flow, or not moving correctly, anything else like that, has the ability to make a much more robust system. And then, of course, going from 1,500 feet of trench and pipe, this is for a typical, larger residential system, down to about 250 feet of trench and pipe. What that means is that these can be installed much more consistently and much quicker than standard systems. And also leave the end customer much less vulnerable for leaks and pipes just by eliminating that much pipe. So going from, a typical, if we look at a residential install here that takes 44 hours, bringing that down to 16 hours. Now for commercial systems, this actually has a bigger benefit because in many places, commercial systems are installed with union labor, so the labor rates for installation can go up significantly. So overall, you can save a lot of money in the project if you're able to reduce that labor by using something like digital sprinkler heads. Damien, do you want to jump in with questions here?
I'll try and knock some of those out.
Sure.
First one, is the head wiring similar to a traditional irrigation system, or can a decoder system be used?
No, it's different because it actually needs its own wiring back to that special controller. A way to think about it is it's kind of low voltage power. It's not high voltage, so it's like a landscape lighting. But we also communicate over that same power line to tell the digital head how to program and what shapes it needs to spray in. So it's not compatible with a traditional with a different controller.
Okay, and let's see, answering there. Got a question from Landon. Residential heads use flex pipe. Golf uses jointed PVC arm to manage minute head adjustments. How does this head connect to the 1-inch PVC main?
So there's actually a flexible pipe there that we provide with each piece. It's kind of like funny pipe. Ray, do you want to talk about that for a second?
Yes. What we've done is every head is packaged with 18-inch length of pipe that has the male pipe fittings on it that go into the bottom of our head and then directly into the 1-inch main line. So that's already supplied with the head.
And the difference there is instead of being a mechanical system where the placement and the fixedness of that head have to be very precisely controlled and adjusted, in our case, you just have to make sure the head is fixed. And then at that point, all the adjustment happens in software. So if the head is off, let's say it's tilted slightly or it's in a different location or anything else like that, the only difference is what you just need to make sure that it can't change its position. As long as it can't change its position, then the shape is actually created in software.
Okay, great. I think that answers that question. We've had a few variations of the same question which is, what about spray shadows created by tree trunks, signs, etc.? And the variations include, small shrub foliage and getting in the way of those streams.
Yeah.
How do you?
So this is generally something that you handle mostly in planning, where you may have two different digital heads that may be on either side, and they can trade off of which parts are in some zones. So you don't have to have like perfectly square zones. You can basically use the fact that one of my digital sprinkler heads on one side will cover half of a tree shadow and the other covers the other. By the way, as long as we're on trees, one of the really important and nice part about irrigating with digital heads is you can actually draw around the trunk so you don't spray the trunk, which turns out to really help eliminate a lot of the fungus and a lot of the diseases that trees can get if their trunks are continually irrigated. So there's no magic here. You do have to have line of sight to everything you irrigate. But in most cases, the way you place the digital head, you can go through there. The other technique we use is sometimes you'll have like a little space like behind an electrical box where you won't want to spend the money to put another digital head in, and that's fine. The system supports like hybrid systems. So you might go back there and just put one little piece of spray, behind a tree like that, or behind a, electrical box or some area that's, too small to justify a digital head. And that's a technique that we see used in a lot of systems.
Okay, great. And let's see. Does the app allow you to figure out or set minimum or maximum precip rates for each head? And I'm pretty sure that's coming up. But
yeah, we'll talk about the programming for that to go through. But yeah, you basically will set the amount of, you'll basically set the number of, the amount of inches of water you want to put down in each irrigation session.
Okay.
And then the system will calculate from that. But we'll see what that looks like.
Yeah, well, we'll keep going in the presentation for now and leave all the other questions for the very end, because we still have quite a few. So
perfect. Okay, so let's talk about design rules for a second. On the right side, so here's an example of a residence, for instance, with various zones. We've placed the digital heads in the middle of the zones. Remember, we're not doing head-to-head coverage here. We're basically going to, there's no overlap between zones. We're basically going to draw a perfect line on one side from one zone and then irrigate to that perfect line from the other digital head on that side. And the system is very accurate, so it'll do a good job of that. Now, the amount of throw that a particular digital head can do, if you look at the chart over there, and then as we're working on working with LandFX in it as well, it looks like there will also be tools inside LandFX to be able to show these rings for this place, and maybe Jake can jump in here anytime to talk about that. But basically, going from 40 psi up to 80 psi, you can see the different throw lengths. So if you're in an area that only has 40 psi, you can still use digital sprinklers. It's just you have to make sure that you're not asking them to throw more than about 25 feet. The other key piece is that the design rules for head placement. So a particular head can water up to about 2,000 square feet. If you look at the smaller area, a narrower area, like on the side of that house right there, you'll notice that the minimum throw is about 5 feet. So you have to, if you've got something that, a strip that's only 3 feet wide, this digital head won't work for that. However, if you've got something that's 5 feet wide, you can do it. Just put the head at the very side, at the very edge of that area, and it'll just water in a 180-degree pattern. So that's the design technique to handle narrower zones. So this is we're going to show you a little bit like how to program the system itself. This is something that we did a lot of work, especially with the installation contractors, to find something that really made sense for them. So rather than doing a lot of math and doing a lot of measuring, it ends up being a really intuitive and actually kind of a fun system to program with. You've hooked it up, you've put the head where the irrigation designer told you to, and then once you're there, it calibrates. So it basically understands how much flow is going through the head, so it knows how far to go through. And then you just pop up the head and you aim it to whatever the corner of your irrigating area is. And you aim it by basically rotating the head with the rotate button and using the plus or minus button to make it throw further or lower until you kind of create a point. And then you just save that point. So basically, if you wanted to create a square, all you do is put 1 point in each corner, and the system automatically connects the dots and draws a straight line between any of those points you go through. So if you had a square that had a curved section in it, you'd put in 3 points for 3 parts of the square, and then for the curved section, you'd basically put points along that curve in order to describe that curve. And there's up to 50 points you can put in there, so you can put in any arbitrary piece. So, this gives you the ability. If you want a star lawn, you can draw a star. If you want a rectangle or a curved section or a kidney bean, all those are possible as long as you've got line of sight from the head to each part that needs to be irrigated. And then once you've done this, it sort of creates a map with these points on it, and you can go through those positions. So if you ever need to adjust something or make it different, which is very rare, you can always go back in there and make a change. By the way, this also gives the property a tremendous amount of flexibility over a traditional mechanical system. I mean, can you imagine, let's say you're at a commercial property and they need to add a shed that wasn't anticipated when the design was done. In a traditional system, once you put that shed in, you'd have to dig up the irrigation system and actually put sprinklers around it in order to continue irrigating correctly. Whereas with an Irrigreen system, you could probably just pull it out and draw a new picture, basically put new points in on the Irrigreen system, and you'd be done. So there's a tremendous flexibility advantage in terms of, say I want to put a vegetable garden in, or there's a new paved section or anything else like that, to basically change the landscaping or change the design without having to change the irrigation system. Now for watering, it completely simplifies what's necessary for being able to set up the watering. The first thing you do is you'd pick up if you look at the left-hand side here, you'd pick out the particular zone you wanted to program. And just like a traditional clock, you have A, B, C, scheduling. You can decide individual days, odd, even, every X days. And then instead of choosing how long you want it to run, you just go directly to how many inches of water you want to put down for each watering event. So let's say I had 4 watering events a week and I wanted to put a little less than an inch of water down a week for a particular area. Well, then I would just scroll down and you could basically change this in 0.055 increments of inches. That's actually the amount that gets down in every revolution. And if you see 4 revolutions there, that's 0.22, and it's 0.22 inches, which is about perfect if I want a little less than an inch put down. So I'd select that, and it will automatically look at the geometry and calculate how long my watering time will be. Now, if you have regular events here, this can also schedule, regular drip or regular spray. And in that case, you just, like a traditional system, you'd put in how long you wanted it to run. So a lot of the calculations involved in getting this right are now in the system itself. So to give you an idea, this gives you, a little bit of an example of like, small systems that go in here as well. This is like a 2-head system. And some of our guys, before they actually do the CAD, when they're pre-built, so this is an example just doing a very rough idea for a customer prior to winning the job and actually doing the CAD part. They'll actually use something like Google Earth and actually put in rough estimates of where the sprinklers would go prior to doing the CAD work. And this is something you can do in this system. It's much easier in terms of quoting a system like this than quoting a traditional irrigation system. And an example, here's one that has 16 heads using Google Earth. Here's a CAD drawing where, in this case, this is an example of a residence that has about 98 mechanical heads in it right now. And if you look at it, you can see the main line, and you can also see all the laterals coming out to each of those sprinklers in that place as well. So that's kind of a full plan on where those sprinklers would go. And if you take a look at it, here's a simplifying drawing with an Irrigreen heads. And one of the things you notice is the amount of pipe went down by there's about 1/3 of the pipe in this. And they went from, somewhere around 98 heads in this one down to 23 Irrigreen heads. in order to be able to water this as well. And remember, that's also all off 1-inch main line. There's no laterals anymore because the valves are in each of the heads. And what we're eliminating here is all the plastic sprinklers, the overlap. As we get more complicated geography, mechanical systems tend to become less efficient and also require much more piping. So for instance, if there's a lot of geometry in a particular area, you know how that the irrigation system can get messy, and that goes away. So overall, just an overview here as well on mechanical places, the design rules, these are all the things we've come to know and love about mechanical. The first, piece is that we have to get head-to-head coverage, lots of heads, lots of pipe, and then we have all the math to sort of match the precip rates in order to create an efficient system. And after we've done that, there's a significant amount of ongoing mechanical adjustment in order to keep that system working well. In many cases, there's about 50% waste because of that overlap and that overspray. With digital heads, it goes down to 1 head per zone. You can water any shape. 80% less heads and pipes, so you eliminate a lot of the infrastructure necessary for irrigation. And then you're using software to control the participation rates. And you're doing that precise mapping via that mobile app. And because you've got that precision, you don't have that overlap and you don't have that overspray. So the overspray part is actually really important because a lot of the customers, especially if there's hardscape around where they are, or it's a front yard situation where the neighbors can see, any amount of overspray ends up being kind of drought shaming. It's very difficult to eliminate all of it in a mechanical system. With an Irrigreen system, because of the precision of those digital sprinklers, you can actually make one that's that's much less susceptible to overspray, where you're just absolutely describing whatever curves are for their landscaping, even if those curves are somewhat complex. So to summarize here, before we get into the case study, we've got this thing up to 50% less water, less labor, so it installs a lot faster, about 2 to 3 times faster, simplifies the design, and because there's that flow sensor in every single system, you're monitoring the actual water use so the customer can see how much they're saving. So it allows you to kind of create actual water budgets and plan and look at budget versus plan in real time. So what I wanted to do now is actually show one of these. And in the example we'll use here, this is from Oklahoma Gardening TV, where they use Dr. Luanella, and he'll introduce himself. But this is the Oklahoma State Botanical Garden, and Dr. Luanella actually teaches irrigation at Oklahoma State. So it was a really interesting case study for us to go through as well. So I'll let this run, and then we'll pick up questions at the end.
Dr. Luanella, we're here at the Botanic Garden at Oklahoma State University. You're the director of this beautiful place here.
Thank you, thanks.
And we're at kind of your front yard of the Botanic Garden. And it's some beautiful Bermuda grass, a little bit of fescue under the trees. And I suppose you have to maintain this, you have to irrigate it, is that correct?
We do. For years, we've been irrigating it by hand, just with garden hoses and sprinklers. But we really wanted to save some labor and also get a better product. And so we've installed a brand new irrigation system here called the Irrigreen product.
Wow. So I see this area here. It's got some zigs and zags and some jogs to it. How do you irrigate that exactly?
Well, that's why we're so excited about this new system. You put one head in the center, and it adjusts its radius based on the shape of the garden.
Wow.
So it's revolutionary. It's a brand new product. No other product does anything like this. And there are lots of advantages to it.
So if I'm doing this, a traditional system, I may have to have, I don't know, several heads here, maybe even a couple of different zones. How does this work exactly?
Well, that's one of the great advantages of it, is that you put that one head in the center. For a traditional system, you'd have to go out to the edges and put heads all along the edges, maybe a few in the center. And if you have corners like we do here, you'd have to put one head in each corner. So for an area like this, it might take 9 heads.
Sure.
Now we just have the one. And if you only have to install one head, you have to do a lot less digging. And that was the other advantage for us. We're a botanic garden. We didn't want to dig up this entire yard. And so we had to do very little digging just to get the one head in the center rather than those all around the edges. We actually have 5 different heads, 5 zones for this entire yard, but it probably would have taken 40 for a traditional system.
Wow. So you got me excited. You guys tell me how this works. Where's the pipe? Where are the heads? How does it work?
So the heads are right off of the main. So we have one main running right down the middle of the yard, and then the heads are tapped into the main. And the other thing about this system, traditionally you throw head to head. So the water from this sprinkler has to hit this. With this, you don't. With the Irrigation system, it's not head to head. So this head throws this far, this head throws that far. So you really have a lot longer radius or a lot longer area that you can water with fewer heads. So that's another advantage.
So how far, so, you know, if we get a little technical here, say I've got a 50 or 60 PSI and say I've got, you know, I know my flow, how far am I throwing, like 10 feet, 50 feet? How does this work exactly?
This head will throw a maximum of about 35 feet.
Okay.
But we keep it at 30. We decided that we weren't going to throw further than 30 feet. So it's throwing 30 feet. So if this head's throwing 30 and this head's throwing 30, the heads are 60 feet apart.
Okay,
which is much further than you would normally have in a traditional system.
Right. And so you've got to show me this thing. How are you going to water this and keep, well, obviously you're keeping it green. So how does it not get the sidewalk wet?
It's all computerized. So Gary Kleinfelter's an engineer that developed this product, and it has a flow sensor on the main. And so you calibrate the system with that flow sensor. And so it knows what flow is coming through the system. And with an app on your phone, you program what distance you want it to throw. So I set the head to be throwing at that sidewalk, and then I set the distance to end just before we hit the sidewalk. And then with the app, you rotate the head, set another point, and you keep going around. And what's really cool is you can set a point over here and set a point over here. You don't have to worry about all those points in between. The computer calculates the radius between those two distances. So it's really, really interesting.
Okay, so if I wanted to do this, say in my home lawn, can you give me a ballpark of what are we talking about with cost and things like that?
It's probably more expensive than, it's definitely more expensive than a traditional system, but you've got savings in product. So you don't have to buy as many heads. You have the savings in the labor. You don't have to do as much trenching. You don't have to buy as much pipe. So, you know, I don't know exactly how it works out dollar for dollar, but there's probably cost savings as well. So this has shown to be as efficient and as uniform as traditional systems, but using about 40% less water. So you've got water savings and water conservation. That's a money saver as well.
So higher upfront costs, but I can save water and save some of that labor to put it in. And it looks like to me, still have a beautiful yard.
It's doing a great job. So we installed it this spring, early this spring. It's been irrigating all summer. We've had rain this past week, but we have not had rain in the middle of the summer. And this is the greenest this lawn has ever been.
So you've got automation, you've got rope.
Okay, I want to make sure to leave time for questions in here as well, but hopefully that was a good case study to kind of think through on that. And let's go ahead and fire away, Dean.
Thanks, Shane. Yeah, we have a stack of questions. So we'll try and get through as many of these as we can.
It's a whole new world.
Yeah, so anything that isn't answered, we'll make sure you guys get in contact with Shane or Ray, as his email is up there. But Ashton has a question about, are there any plans to offer higher pop-up heads? And his context is his business installs a lot of native seeded areas on ranch landscapes, which use that style of higher pop-up heads already. Right. So,
yeah, there are plans. We don't have a release date for it yet. We're also finding that some folks that are doing a higher pop-up area, like for instance, if they're doing native plants, are actually burying the head so that the top 6 inches are already sticking up. So that gives you, somewhere in the order of 11 inches of pop-up. This is an area if you don't have to mow it. Let's say it's in an area that has, bark chips or something similar like that. So we have seen folks do that to get them kind of 11 inches of pop-up with the current heads. But in the future, we probably will develop a higher pop-up as well. That being said, if you got an area around, let's say you've got some shrubbery or something similar like that, if you got an area that's fairly open, you can see it throws at that 45-degree arc. So as long as there's not tall plants in front of it and you still have line of sight to what you want to irrigate, you can still use a digital head. But traditionally, most of what we have, I would say about 80 to 90% is short stuff. Not necessarily turf, but like turf, no-mow, things that tend to be a little bit shorter.
Okay. Can rain and moisture sensors be connected with this type of system?
So rain sensors and moisture shutoff sensors, absolutely. So there's a place on the controller to be able to connect them in there to inhibit rain. And as we go through this year, we're also turning on our own ET weather data system that'll actually help, just like a ratio controller, where bring down weather data to do offsets.
Great. Question from, well, the question is, can these heads operate under a flow of 8 to 10 GPM?
We tend to really look for those things to go through. It depends on the situation and the pressure, but really we want at least, I would say at least 7 GPM on that part to go through. Below that, they're not going to function well.
Okay, and I'm just trying to get through some of these questions. There are so many.
Yeah.
But what is the life of one of these heads? And also, part of the same comment, how do you calculate the flow analysis?
Okay.
Two-parter.
Shoot, two-parter on that one. So I'll take the first part. Actually, Ray, do you want to handle that one?
As far as calculating the flow?
Sure. So the life, I'll start off with the life itself.
Sure.
So the systems themselves have undergone pretty rigorous testing. These are heads that we aim for about 15 years of service before they go through. And the motors and things like that are checked to run, have solid engineering margins at 10 years. So it's really designed to be a system that you put in and you forget about. And the system also comes with a 3-year warranty, which is one of the longer warranties that's out there as well, to make sure that we stand behind, behind those products. On the flow calculations, Ray, do you want to have answer that? I know it's calculated inside the software. Is the idea of how do you get a hold of those calculations?
Right. Well, we are working on a chart right now, but basically when it's throwing about 5 feet, the flow is around 2 gallons per minute. And when it's throwing 30 feet or 35 feet, we're getting up to about 8 gallons per minute. So it varies between those depending on the distance. But it's not linear, it's a radial calculation. But it's pretty straightforward for us to create a table for that, and easy to put in a software program like LatinFX should be able to do that pretty simply.
Okay, so we've got another question here that kind of links to something you've already talked about, is the shrub planting areas and plant material knocking down spray stream. But similar to that, there is, questions talking about the deliverable of the water to different plants in that sort of multi-leveled sort of garden bed.
Yeah.
What's the success like there, or?
That's something that's fairly new for us. So we can put you in touch with other folks that have gone through, but if you've got an application where you're doing sort of multi-level garden, just contact us and we can put you in touch with the right folks.
Okay, I got a question here about the head specifically, and if it malfunctions, are settings lost, like the point settings that you've already laid out, and how are you able to, I guess, figure out the issues that come with any sort of technical or breakdowns in the product, if that situation arises?
Sure. So first of all, the heads, we usually have them the heads all have connectors that are right next to the head that we generally put in a little junction box that's right next to the head. So if you ever need to replace the head, pulling it out, replugging in the new wires, putting the new one back in there and reburying it is a fairly straightforward operation. Ray, do you want to handle the question about where the program's saved?
Right. The programs, the mapping points are saved in the controller and also in the head. But we have found that when you are replacing a head, it's usually you're better off just remapping it. And quite frankly, it doesn't take that long. Once you've programmed 4 or 5 of these zones, it's pretty easy to program a zone in about 5 minutes. once you've done a few. The first time you do it, it will take you longer, but once you've done a few. So we've run into that where if you have to put a new head in, you can download the points down, but it's sometimes easier just to go ahead and reprogram it while you're standing there because you're digging things up and it just makes sense to just do it again.
Okay, I got a kind of similar question on the head maintenance. Do you need to adjust the heads regularly to keep them accurate, or are they pretty, reliable from that standpoint?
No, on the head itself, other than the sealed area where the motors are, there's no real moving parts. It's basically just coherent streams that come out on that side. So the only maintenance would be if there was a problem, like a line wasn't blown out correctly, you can unscrew the head and there's actually a screen below where you can clean out any debris. But in general, they're pretty much maintenance free.
Okay, another question here. Are you able to winterize the system with these heads? Or are they able to be blown out without damaging the system?
Yeah, on the controller itself, there's a special button for blowout. So you can blow it out just like a traditional system and it'll open up the valves so you can blow it like a traditional system. The only thing you have to do is you do have to enter blowout mode on the controller before you blow it out. Otherwise, the valves in the head will all be closed and blowouts won't be successful.
Okay, and another really good question actually is, will it read elevation change? How does it handle that?
Yeah, so the really interesting thing about elevation change is because one of the advantages of programming in the field is that if you have different elevations, and when you're actually using you saw Dr. Luanella using the app to actually set the points and spray further out, you can actually spray to that point, to that elevated point, to basically describe any pattern. Now, if the system's on a slope, we have you go ahead and mount the controller so that it is at the same angle the slope is, if you're irrigating something else like that. But that allows you basically to put in the pattern as it really needs to be in terms of valve settings to irrigate that area. So it actually handles slopes quite well. The other key part on slopes is we're all familiar with putting water on a slope and having it run off. So you get kind of dry on top and then you get kind of a swamp at the bottom. If you remember, the system puts down about 0.055 inches, and it takes about 5 minutes to go through. So we find that this is a better technology for irrigating, especially like turf slopes, because it goes down, puts that 0.055 inches down, and then there's 5 minutes for that slope to absorb that water before it will be irrigated again. So you have a lot less runoff than you would with a traditional mechanical system.
Great. And okay, let's see. Estuardo has a question about how many digital heads can the controller handle?
The current controller can handle 8 digital heads for one controller, and obviously they're expandable, so you can put more controllers on to handle more. We have a controller that's coming out kind of at this summer that will handle up to 24 digital heads. And remember, each digital head is kind of the equivalent of 9 or so mechanical heads. So you can do a fairly large commercial system with that next box that's coming.
I've got a 2-part question, well, actually a 3-part question, it looks like. That first part has been answered. Is it available to commercial settings?
Mm-hmm.
And the second part is, are you able to offer these services based on projected water savings? And that's performance contracting, paid-based performance?
Sure. So the system itself will record how much water is used for each event. And then you can essentially use the CIT study to figure out how much water you'd have to put down with an equivalent mechanical system and do the math, and that creates savings. So for some customers, what our contractors will do is actually, we can provide these. You can get it off the controller right now, and eventually we'll have the ability to get this off the cloud in terms of reports. But basically you'll be able to show each month how much water was saved by using a digital sprinkler system versus a regular one. And then, transport that to the customer's water bill, knowing sort of what tiers they're typically in, to how much dollar amount savings that tends to be. But for a typical home in a high water cost area, that's savings of somewhere between $600 and $1,200 per year in lower water bills.
Okay, I got a question about the heads only tying to a 1-inch main line, or is there a maximum mainline size that the head can tie into? Are there options available there?
Ray, do you know the answer to that? I know we recommend 1 inch, but you can go ahead.
It can certainly run off of a larger main line. It's just that we recommend 1 inch as a minimum through the system to make sure you get that good 8 to 10 gallons of flow, even if you're a couple hundred feet away from the water source.
Okay, perfect. Thanks for that. And I think we'll try and just get one last question in as we're really kind of reaching our time limit here. But is Irrigreen set up for homeowners to install on their own in their own systems, or does it have to be installed by a trained professional contractor?
No, right now we're doing it through the professional channel, and again, that's sort of also respect to the professional channel right now. But that's the way we're currently installing.
Okay, well, that, I think that's a good point for us to kind of close this this really, really interesting webinar out. And I just want to thank Shane and Ray for really putting a lot of time and effort into getting this together for us. It's been a great discussion, and we do have some other questions that didn't quite make it into live question time, so we'll actually get those sent over to you so you can have further discussions with those people. But again, if you do have any other questions that come up later on, Shane's contact information is on that slide. So please reach out. I'm sure they're eager to continue discussions and talk about this sort of stuff. So thank you, everyone, for attending today's webinar. And
thank you so much, Damien. We really appreciate it, and thanks to the LandFX crew for having us on. It's a great product, and we look forward to working with you guys. And had fun today.
Yeah, thanks very much, guys. So have a great weekend, everyone.
All right, take care.
Yep, thank you.